AI-powered post-quantum cryptography risk assessment. And as we can see in today, most of the topics is all around the post-quantum cryptography and the migration and using of the AI to help on the detection of the migration of or the migration to the post-quantum cryptography. And my talk builds on that theme, but with a broader perspective. So the migration is, of course, essential, but before we can migrate, we need a visibility or a full visibility of what cryptography we have. So, do we actually know what cryptography we already have in our system, where it exists, and how exposed to the quantum risk? All these questions, and without that full picture, it's impossible to understand how vulnerable those cryptographic assets are to the quantum risk. And that is where our PQC-RA comes in. So we aim to tackle the critical middle steps, and we want to show how we can use AI not only to detect and understand where cryptography hides in code or network traffic, but also we want to show how we can use AI to assess the risk and prepare organizations for a smooth and secure transition post-quantum cryptography. But before we go and look at the PQC-RA, let me give you a bit of background on the organization behind this work. I know Amit Gupta was earlier on the panel, give an overview of the equipped IT. But a quick background on the PQC-RA is developed as a result of a collaboration project between equipped IT and Edinburgh Napier University. And equipped is a national security focused UK software and technology company established in 2017 and trusted across government for delivering secure and high assurance solution. Regarding the work we do, equipped do design and developing and implementing secure platform and frameworks that improve how government handles sensitive processes and data. And the company focus has always been national security, working across official and higher tier platforms where resilience and trust are very critical. So Equipped is specialized in three main areas, including the secret collaboration environment, where we involved in building products for secret classified environment in the UK, including projects you may heard about, some projects like Rosa platform for Cabinet Office, Citadel for the FCDOS, and additionally, Equipped is also expert on building and designing the national security applications. And regarding the research and development, Equipped is also contributed to the NCSC initiate program, where for 4 years Equipped worked collaboratively to develop the what we called the CDHA, the cross-domain hybrid architecture framework. And additionally, now through the KTP partnership, or what we call it the knowledge transfer partnership between Equipped and Edinburgh Napier University and in collaboration with Innovate UK, Cubed are now pushing the boundaries in advanced cryptographic research, not only in post-quantum cryptography, but also in areas like homomorphic encryption, zero-knowledge proof, and multi-authority attribute-based encryption. Here are some of the partners and current and past project. But beyond these platforms, I want to show you the partnership behind the PQC-RA, as the project was a result of this collaboration between Edinburgh Napier University, Cube, and supported by Innovate UK. Let's take a closer look at the challenges that we address by using the PQC-RA, or the post-quantum risk assessment. And from the great talks that we heard today, as you can see, most of them highlighted the NIST timelines, and we are now approaching the quantum era. So the quantum era is not something forward concept. It's approaching much faster than many organizations are prepared for. So the real question will not be just how quantum will impact our cryptographic system, but when and are we ready for this transition. So here we can see the summary of where we stand today, mapping to the NIST guidelines and timeline. But in summary, the NIST has made it very clear that by 2030, most of the traditional public key methods that we have relied on for decades will be formally deprecated. And by 2035, many of them will be completely disallowed. So to address this, the NIST has already finalized the first wave of post-quantum standard, which will form the backbone of our future security. As you can see on that table, now the new standards, the FIPS 203, FIPS 204, 205, and 206, which will replace the current cryptography. These include the ML Chem for key encapsulation, ML DSA for digital signature, including the dilithium, 7X, and Falcon. So think about it for a second. 2030 is less than 5 years away. In cryptographic migration terms, that is basically tomorrow. So the clock is ticking. Migration is no longer optional, and the timeline is not just something generous. The question is every organization now faces is, do we know what cryptography we currently rely on, and how do we plan the transition before the deadline? And that brings us to the real challenges, which is detecting and assessing cryptography across different locations in our system. Let's take closer look at why this is so difficult with the tools we have today. So moving to the post-quantum cryptography is not like flipping a switch. It's a journey. It requires careful planning, step-by-step migration, and continuous monitoring. And that journey is harder than it sounds. One of the biggest challenges is that cryptography itself is often invisible. It hides deep in code or in libraries and even inside network traffic. So the question would be, how many of us could right now point to every place where our organization cryptography is used? So for most of us, it's a black box. And when we turn to the current generation of crypto detection tools, we find that most of the tools that are unflexible often require custom queries or tied to language specific setup, which makes them not flexible and also not AI powered, which means still blended spots remain. And many of them also rely on cloud services, make them unsuitable in secure or air-gapped environment where some of the most sensitive systems actually lives. So simply, these tools often miss something, leave us with the dangerous blind spots. And this actually where uh, where the PQC-RA come to help to shine a light into those blind spots, to give organizations full visibility of their cryptographic assets, and to prepare them for secure and confident transition to post-quantum cryptography. So, how we tackle these blind spots, and how do we make sure migration to the post quantum cryptography is not just possible but confident and secure? That's exactly why we developed the PQC-RA. Think of the PQC-RA as your compass for navigating the post quantum transition. It doesn't just scan a single layer or a single file. Instead, it uses AI to give you end-to-end visibility of your cryptographic posture across different locations. And it acts as a quantum risk assessment engine. So measuring how exposed your assets are and how ready they are for post-quantum cryptography. Third, we can see also the its migration and strategy planner, so guiding you step by step, so you don't just know the risk but also what to do next. So it's also support compliance and advisory by generating what called the CBOM, or the cryptographic bills of materials, to help with audits and supplier transparency. And in short, that the PQCRA will help to shine and light all these blind spots. And it doesn't just stop there. It tell us how we can fix them. So uh, the PQCRA, we can look at how this work and how we use the AI to perform this. Uh, when we talk about AI in cybersecurity, we think of it just being applied in very narrow ways, detecting anomalies here or parsing code there. But with PQCRA, we have taken much broader lens. Our AI does not just look at one slice of the problem. Instead, it analyzes the entire cryptographic posture end to end. And here how it's work. We start on the left, which where we have source code. This is the raw inputs, like source code. That code is broken down, chunked, and parsed so that it can be actually be understood at the scale From there, we generated embeddings. These were the AI models like Olama, Hugging Face, Gemini, or even using OpenAI to help to do the embedding and indexing the source or the traffic. Uh, there's different ways for these embeddings, but uh, those embeddings using the embeddings models will index and store this indexing and think of this indexing as creating a searchable map of where cryptography lives in our system. On the right, we apply a query engine and a second set of large language model or the LLM. These models will also uh, use to query the indexed source code and get the finding from this search. And the PQC-RA engine takes all this data and finding and turn it into something actionable, like creating of the C-bomb of all the cryptographic components, risk classification and scoring, then concrete recommendation and provide migration plan.
Five
Uh,
minutes.
okay, all right. So all of this comes together in the PQC-RA dashboard, giving decision makers a clear visualization picture of their cryptographic assets and position. Uh, Moving on to see how this can be used in practice and how users can use it to achieve their analysis and get a roadmap for post-quantum transition. And here where the PQC-RA dashboard come to help. As you can see from the screenshots here, we start by selecting the source type, and for this to make it flexible, as code can be stored in different location, either locally or in a repository. We can select between four different options, either local folder, remote repository, or backup file, or even live traffic. If I select it, for example, live traffic will give me an option to select the interface, the duration, and then I can start the indexing to create this cryptographic map of all the findings, and then we can run the PQC-RA report and finally run the visualizer to get the result visualized on the web interface. And here an example of the PQC-RA visualizer, where you can see the total cryptographic assets in your system or the source code divided by types and primitives. And also you can see the risk analysis part, and these risks are now mapped to the NIST deprecation guidance, show you the status of each cryptographic assets. Is it deprecated or at risk or even approved or post-quantum approved? You can see also breakdowns of all these risks and their status. And additionally, we can also see the vulnerability scan. And for the vulnerability scan, our scanner goes beyond just the deprecated algorithm. It maps against the MITRE and the CWE, the common weaknesses enumeration, to identify the insecure coding patterns and flags them or flag the script to that NIST has already placed on the deprecation path. So in short, it connects real world threats to the crypto you are actually using. And you can see also the C bomb generated using the Crondex standard with clear information, providing also some recommendation and guidance with risk status score and the finding and line snip, and show you some details of each finding. And finally, we come to the end of this journey. And as we wrap up, we can see the full picture. So the post quantum journey now is mapped. Remember, migration is not just one of project. It's a continuous journey, and the PQC-RA is here to guide organization at every stage, turning all these hidden things into a clarity. So to summarize this, we started by uncovering the hiding cryptography. No surprise, no blind spots. You will have a full view of what cryptography you have in your source. Then classify risk and align them with the next guidance. Give give you a structured or trusted roadmap. And next, we build the C-BOM for supplier and auditors to have full visibility. And finally, we plan the migration itself, either system by system or asset by asset, for smooth, confident transition to post-quantum cryptography.